In this lecture, we'll be taking a look at how we can rewrite the binary search algorithm that we covered in the previous lecture. Now over here, what we'll be doing is we'll be enhancing our binary search approach by creating a recursive function. So if you look closely at the binary search algorithm, what we are doing in that is that we are shortening the list on every iteration. So it's like calling the same function but with different values, and that's what we have done over here. If you look closely, the new method that we have created, recursive binary search, it now accepts three parameters. One being the value which we have to search, and the other two is lower and upper value. So initially, as we were saying, that we will have a sorted list, and the lower value will represent the first item in the list and the higher value will represent the last item in the list based on their index position. So here index position 0 refers to the first item in the list, and numbers.count -1 represents the upper value in the list or its index value. Now what we are doing over here in the recursive binary search is that first thing, we are checking whether the value that we have passed is less than or equal to upper value or not. Now if that's the case, then we are going and finding the mid value. Once the mid value is there, we are checking whether the value that we are searching is less than the mid value or not. And if it is less, then we are doing a recursive search, and in this case you can see that the upper value gets modified or updated. So now a shorter list is being searched. In case the value is right there, then obviously the index position is returned and user is made aware that here's the index position where the value exists. If that's not the case, then we are again doing a search, but this time the list is updated, and here you can see the lower value is now updated as mid +1. If this condition itself is not true, in that case we are simply saying that there's no way we can find this value in this list. Basically, the value does not exist. So let's go ahead and run it now. And as you can see, the result is coming up at index position 9. So if you count from 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So the first occurrence of the value 96 in this list is at index position 9. And here's how we have achieved it using recursive binary search.